This is part one of the series Calculus Prerequisites, and the intent of this series is to give you an overview of the concepts and skills that you're going to need to be successful in a university level calculus class. Now, this is by no means a comprehensive survey of the concepts and skills you're going to need. It's simply intended to give you an idea of some of the things that you're going to need to brush up on if you're a little rusty, so that you're able to do the level of rigor in a typical calculus class. The expectation that I'm going to make in these videos is that you've already seen this material in the past, and this is simply a refresher of information you've already worked with in the past, just to tell you what you need to refresh yourself with. If you find that any of this material is brand new to you, I would strongly suggest that you check out some additional resources in that area so that you don't experience any frustration when I gloss over some concept that you're unfamiliar with, expecting you to have already seen it. All right, let's get going. And the first thing we're going to start with is factoring. To start with, we're going to look at three of the most common things we're going to encounter. The first one is the distributive property. Now, you're familiar with this from the standpoint that you're used to seeing some value outside being multiplied by two or more terms inside a set of parentheses. And you would say we would distribute this a across these terms inside and end up with a times x plus a times y. Well, the same works in reverse. If you have this initial concept and you need to pull out the factor of a, that's still a distributive property, but it's a form of factoring. So you're factoring out the a here, dividing out an a from each term, pulling it out to the outside, and what you have left is x plus y on the inside. Then we have the difference of two squares and the sum and difference of two cubes. And so in the difference of two squares, we have two squared terms subtracted from each other. And the plan is very, very simple. It's the difference of the two terms times the sum of the two terms. And if you were to go through and multiply these through, you'd have a times a, which is a squared. Then you would have a times b minus a times b. That center term cancels itself out. And then you would have negative b times positive b, which is negative b squared. And that's why the difference of two squares works. Sum and difference of two cubes is a little bit different, and it's a very straightforward pattern. If you take a look at what this does, when you have the difference of two cubes or the sum of two cubes, works out the same. You take the cube root of the first term, which is a cubed is a cubed. You take the same sign, and the cube root of the second term, b. Then your multiple here is the first term squared, so that would be a squared. So you take this term and square it. The opposite sign, so if this is negative, this would be positive. Then the product of the two terms, a times b, always a plus sign over here, and the second term squared. So again, that's the first term squared, right here. The opposite sign, the two terms multiply together, a times b, with that opposite sign from this sign, and then the second term squared. Same thing works for the sum of two cubes. Take the cube root of the first term, same sign, cube root of the second term. For the first term in the second factor, you take the square of the first term, opposite signs, product of the two terms, a times b, and always add the square of the second term. And if you were to multiply these through, you would get this. Multiply these through, you would get this. All right, let's look at a couple of quick examples just to refresh us on how to do these. In the first example, we clearly have the sum of two cubes. And of course the key is the recognition that we have cubes involved here. Clearly that's a perfect cube, and 125 is the cube of 5. 5 times 5 is 25. 25 times 5 is 125. So our two factors are x and 5. So to start off, we take the cube root of the first term, x, same sign, cube root of the second term. That gives us our first factor. For the first term of the second factor, it's the square of the first term, different sign, product of the two terms, always a plus, and the square of the second term. And if we were to multiply these through, we would end up getting this. X times x squared is x to the third. X times negative 5x is negative 5x squared. X times 25 is plus 25x. 5 times x squared is plus 5x squared. 5 times negative 5x is negative 25x. And 5 times 25 is 125. You can see that the first two x squared terms cancel out, the 25x's cancel out, and you're left with x cubed plus 125. All right, let's move on to the next one. Here you can see that we have x and 4. This is the difference of two cubes. Same idea. Take the cube root of the first term, same sign, cube root of the second term, square the first term, different sign, product, and the square of the second term. And it's always going to be positive. All right. Now, sometimes you may have a term in front of one of the other terms. So here we have a cube. 27 is 3 cubed. And u is a perfect cube. And again, we have 125, which is 5 cubed. We do the exact same thing. In this case, though, what we're going to do first, I'm going to factor out, using distributive property, I'm going to pull out a negative sign. So what I'm going to start with is pulling out the negative. Then I have 27u cubed minus 125. That gives me a negative of a difference of two cubes. So that's going to equal negative, and then my first set of terms is the cube root of the first. Well, the cube root of this whole thing is 3u. So that's 3u. Then same sign, negative. Then the cube root of this second term, 5. Now I start my second factor and I use these two terms. So the first one is the square of the first term. So the square of this is 9u squared. Opposite sign, product, 15u, always positive, and the square of the second term. So there's not a whole lot different. The only difference is if you have this term up here, you have to make sure you include it in here. All right, here we have an example of 2 of them. Now, this one is going to be a little bit different. To recognize what's going on here, it looks like we have a difference of 2 squares. This is a quadratic form of 2 squares. And so what we have here is 9x squared, and we have 4y squared. That's our first one. And so the product here is going to be this set of factors, set of terms with the opposite sign. So this is going to be 9x squared plus 4y squared. But now here we have another difference of two squares, because 9 is 3 squared, and clearly x squared is a perfect square. 4 is 2 squared, and y squared is a perfect square. So this next set, we're going to have 3x minus 2y, and then the next set of terms is going to be this with the positive sign, 3x plus 2y. So this is the difference of two squares here, and then we just copy back down the sum of two squares because this doesn't have a factor. This can't be broken apart. So we have 9x squared plus 4y squared. So this is this factored out. And one last example down here. This is going to be kind of a funky one. Now sometimes you have to use some pretty good introspection skills. But the first thing is look at what's common. Well, clearly both of these have a y term. So I'm just going to pull out a y first of all. And the second thing is to see if there's anything common here. Well, it looks like there is. There's a 3 in both of these. If I divide 1029 by 3, I get 343, I think. So we're going to pull out a 3 out front here. And 1029 divided by 3 is 343. The y was gone, and we have this x cubed here, plus 24 divided by 3 is 8, and y to the third. So now clearly you can see we have a difference of 2 cubes. 8 is 2 cubed, and 343 is 7 cubed. So this is going to be 3y. And then we have a 7x. Same sign. This is the sum of 2 cubes. Cube root of 8 is 2. Cube root of y cubed is y. Then we have the square of the first. So 49x squared. Different sign. Product 14xy. And then the square of the second one. Always plus. And that factors out this ugly monster. In the next part, we're going to look at a different type of factoring called factoring by grouping. So I will talk to you in the next video.